Hello viewers, myself is Dr. Vadiraj B. Tangod, Assistant Professor, Sri Jagadguru Tontarariya Government First Aid College, Mundargi. In this video, I am discussing about free electron theory of metals. In that, this is first lecture on this series. This is for BSc program under physics, especially solid state physics. It is for 6th semester and this is for first session. Learning objectives of this session is to know the concept of free electron theory of metals, to understand the Drude and Lorentz theory, properties of metals, derivation of Ohm's law. And outcomes from this session is knowledge of properties of metals, classical theory of metals, thermal and electrical conductivities and properties of metals, derivation of Ohm's law. Prerequisites for this discussion is concept about basic properties of metals, concept about thermal and electrical conductivities, and Ohm's law. Prescribed syllabus from Karnataka University is free electron theory of metals, classical free electron model, expression for electrical and thermal conductivity, Widman-Frange law, failure of classical free electron theory. And we will look up properties of different metals. We know metallic conductors obeys Ohm's law, which states that the current in the steady state is directly proportional to the electric field strength, that is I is proportional to E. So we know V is equal to IR is the Ohm's law, the same law I is proportional to V, therefore the strength of the electric current is directly proportional to the potential difference across the conductor provided temperature and physical conditions remain same, that Ohm's law obeys in all metals. And we know metals have high electrical and thermal conductivities. At low temperature, resistivity is proportional to the fifth power of the absolute temperature, that is rho proportional to the T to the power of 5. For most of the metals, resistivity is inversely proportional to the pressure. Resistivity of the impure specimen is given by Matheson's rule, that is rho is equal to rho naught plus rho of function of temperature, where rho naught is a constant for a given impure specimen and rho of T is the temperature dependent resistivity of the pure specimen. Near absolute zero, the resistivity tends to zero, that is it exhibits the phenomena of superconductivity by few metals. The conductivity varies in presence of magnetic field. This effect is known as magnetoresistance phenomena. Above dBASE temperature, the ratio of thermal conductivity to the electrical conductivity is directly proportional to the absolute temperature. This is known as Widman-Frange law, that is thermal conductivity K divided by electrical conductivity sigma is directly proportional to the absolute temperature T. So now we will be look up about classical free electron theory of metals. The free electron theory is based on the following assumptions. A. In metals, there are large number of free electrons moving freely within the metals. The electrons revolves around the nucleus in an atom. B. The free electrons are assumed to behave like gas molecules, obeying the laws of kinetic theory of gases. The mean kinetic energy of free electron is equal to that of gas molecules at the same temperature. The electrical conduction is due to the motion of the free electrons only. The positive ion cores are at the fixed position while free electrons undergo in-ascent collisions in an ion core. D. The electric field due to the ion cores is constant through the metal, that is free electrons move in a completely uniform potential due to the field fixed in the lattice. the repulsion between the electrons is negligible. When an electric field is applied to the metals, the free electrons are accelerated in some direction opposite to the direction of the applied electric field. Electrical conductivity, drift velocity, and mean free path. In metals, free electrons move freely through the crystal lattice. In absence of applied external field, the net current due to the moment of electrons is zero, since they move in all directions. In between two collisions, the electrons move with uniform velocity. During every collision, both the direction and the magnitude of the velocity changes. In 1900, P. Joule made use of the electron gas model to explain electrical conductivity in most of the metals. Ohm's law, we know, governs the electrical conduction in metals at constant temperature. The current I through the wire is directly proportional to the applied potential difference V across the wire. That is, I is proportional to V, or I is equal to V by R, where R is called constant resistance of the wire. Now we will be explain the Ohm's law. When an electric field is applied to a solid, potential difference is maintained between the two ends. The electrons will now move from along the direction of the applied field. The velocity of the electrons will directly depend upon the applied field. Higher is the field, greater is the velocity, and consequently higher would be the number of electrons per second through unit area. That is, current passing through the conductor will be higher. According to kinetic theory of gases, we know kinetic energy is proportional to kBt, that is, half mv square is proportional to kBt, or it can be written as half mv square is equal to 3 by 2 kBt, called as equation number 1, where E is the electric field intensity applied to a conductor, E is charge of an electron, m is mass of an electron, v is velocity of an electron, kb is Boltzmann's constant, and T is the absolute temperature. Assuming that after each collision with the ion or atom, electron starts with a fresh velocity v, and in time t between the successive collision is subjected to the influence of electric field, hence it experiences force E is given by F is equal to ma, that is from Newton's second law of motion, where F is force, m is mass, a is an acceleration, and F is also force is also experienced by a charge in electric field. E is given by F is equal to EE, and equating about these two equations, we got ma is equal to EA, or acceleration is equal to E divided by m. So if lambda is the mean free path of the electron, then the time tau is the time between two successive collisions is given by tau is equal to lambda divided by v, where lambda is the mean free path, v is the velocity, tau is called time taken. It is also called as relaxation time. Average distance traveled by an electron in time tau is given by s is equal to half a tau square. We know acceleration is given by E divided by m, and tau is given by lambda divided by v. Therefore, distance traveled by an electron in an electric field is given by half into E divided by m into lambda divided by v whole square. If v is the average velocity of the free electron, then v bar is equal to s by t. It is half E divided by m into lambda divided by v whole square into v divided by lambda. Here v get cancelled, lambda and lambda get cancels. Therefore, our equation can be written as v bar is equal to half into E divided by m into lambda divided by v, or it can be written as v bar is equal to half E divided by half mv square into v divided by 2 into lambda, or average velocity v is equal to half into E divided by 3 by 2 kBt into v by 2 into lambda, because half mv square is equal to 3 by 2 into kBt according to kinetic theory of gases. Therefore, average velocity is given by E divided by lambda v divided by 6 kBt. If n is the number of the free electrons, per unit volume in a conductor. I is the current density per unit area normal to the current direction. Then current I is equal to Ne into V bar. N is number of free electrons, E is charge of each electron, V bar is the average velocity of the electron according to kinetic theory of gases. Or it can be written, it can be replaced by V bar is given by I is equal to Ne into Ee divided by lambda V divided by 6 kBt, or I is equal to Ne square E divided into lambda V divided by 6 kBt. Or from this equation, we conclude that current flowing through a conductor is directly proportional to the field strength, that is applied electric field E. It is called Ohm's law. So hence, if you have any queries, you may free to call with me. Thank you one and all for your very good patience. Thank you one and all.